Here we have the example for special probability distribution. In a production process of cup, it is known that on average, 40 cups have cracked in every 1000 cup produced. So here we have the situation. 40 over 1000 and the probabilities of cracking is 0.04. Number 1. Find the probabilities that at most 3 cups having cracks in a random samples of 10. So by referring to this case, where we have the title is binomially distributed with n is equals to 10 and the probabilities of crack is 0.04. So the question would be probabilities that x and 3. By referring to the question, at most 3 cups. So it means that less than or equals to. So by referring to the situation, what we have to do is to modify and we have a new formula 1 minus probabilities that x greater equals to 4. By referring to the table, where we have 1 minus, for the probabilities x greater equals to 4, it equals to 0.0004. So simplify the situation. The probabilities that x less than equals to 3 is equals to 0.99996. Second part. If the probabilities that no cup in K cup selected at random having crack is 0.12, determine the value of K. So in here, the title is binomially distributed with n and 0.04 crack. So given the question, probabilities that no cup, so means that x is equals to 0. In K cups, so means that the n actually represent the K. So the answer is 0.12. By referring to the formula for the binomial distribution, where we have NC0, 0.04 power of 0, 0.96 to the power of n is equals to 0.12. Simplify the situation, NC0 we have 1. Same goes to 0.04 to the power of 0, we also have 1. So we have 0.96 to the power of n is equals to 0.12. My suggestion is to ln both sides. So by using the properties of ln, we can bring forward the n if we have ln. So n is equals to ln 0.12 over ln 0.96. So the value of n is equals to 51.94. If we round up the situation, n is approximate as 52. So the value of n, it is actually is a value of K. Number 3, find the probabilities that more than 2 cups have crack in a random sample size 200. So x is binomially distributed with 200 as n and 0.04 for the title crack. Next, we have the probabilities that more than 2, so where we have the value 2, more than 2, so x is greater than 2 as a questions. By referring to the title, where we have n is greater than 50, so means that binomial distribution is not suitable. Next, x is Poissonly distributed, where we have lambda as the mean, where we have np. Multiply the 200 with 0.04 and we will have the value 8. So by referring to the diagram, first what we have to do is the value of np must be less than or equals to 5. So for this case, Poisson distribution is not suitable. Next, move on to the normal distribution with the lambda or the mean or the mu is equals to 8. And the variance is 7.68, where we have n, p, and q, which is 200 multiplied with the 0.04 multiplied with 0.96, and we will obtain 7.68. So my advice is express the situation in standard deviation square for the variance. So we will have the situation from the binomial to the normal. So do remember to have the continuity correction. So step number 1, kindly have the correction. So where we have x is greater equals to 2.5 for the correction. Second step is to standardize the situation. So where we have z is greater equals to 2.5 minus 8 over square root of 7.68. Simplify the situation. Z is greater equals to negative 1.98. Next, by referring to the diagram, then the location, then the region, where we have z greater and equals to negative 1.98. Next is to modify the situation, where we have 1.98 and we have the region on the left. So the formula will be 1 minus d's part, where we have probabilities that z greater equals to 1.98. By referring to the table, where we have 1 minus 0.0239. So as a conclusion, the probabilities that x greater than 2 is equals to 0.9761. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.